Imagine standing in a darkened observatory, alone beneath a dome of stars, gazing at a distant galaxy glowing faintly against the black canvas of space. You track the motion of stars spiraling at astonishing speeds, and something doesn't add up. According to everything we know, gravity, mass, Newton's laws, those stars should be flung out into the void. They should not be moving that fast. Yet there they are, orbiting at breakneck speed as if held by the invisible hand of some unseen force. It's as if the universe is whispering a secret and daring us to listen. That secret. Most of the universe is missing. Dark matter. It's the name we've given to an invisible substance that doesn't emit light, doesn't reflect it, and doesn't interact with ordinary matter in any way we can directly detect. Yet it exerts a gravitational pull so powerful that it binds galaxies together, bends the path of light itself, and may even determine the ultimate fate of the cosmos. Right now, everything you see around you, planets, stars, galaxies, nebulae, black holes, people, oceans, atoms, that's less than 5% of the universe. The rest is a mystery, and dark matter alone makes up more than 25% of all that exists. It all started with an anomaly, a whisper from the cosmos. In the early 1930s, a Swiss astronomer named Fritz Zwicky was studying the Coma cluster, a dense gathering of galaxies over 300 million light-years away. He measured their mass, estimated their gravitational pull, and then compared it with how fast those galaxies were moving. The result was shocking. The galaxies were moving so quickly that by all logic the cluster should fly apart. But it didn't. Something unseen was holding it together. Zwicky called it Dunkel, materia, dark matter. He had discovered a cosmic ghost, and yet for decades no one took him seriously. Fast forward to the 1970s. Enter Vera Rubin, an astronomer who would reshape our understanding of the universe forever. While studying the rotational speeds of stars within spiral galaxies, Rubin noticed something strange. Stars far from the galactic center were moving just as fast as those near the core. According to the known laws of physics, that was impossible. The outer stars should be moving slower, unless there was something massive, invisible and everywhere, an enormous halo of unseen mass surrounding each galaxy. Rubin's work confirmed what Zwicky had seen 40 years earlier. Dark matter wasn't just a fluke in one distant cluster, it was everywhere. These revelations cracked open a door to the unknown, a door we're still peering through today. Since then, astronomers and physicists have built an entire branch of cosmology around dark matter. We can't see it, but we know it's there because of how it shapes everything we can see. It acts like a gravitational scaffolding, forming the cosmic web, the vast, interconnected structure of filaments and voids that cradles galaxies across the universe. Without dark matter, the early universe wouldn't have had enough mass to collapse into stars or galaxies. In fact, without dark matter, we wouldn't be here at all. And yet, for all its influence, we still don't know what it is. Could it be made of exotic particles, WIMPs? Weakly interacting massive particles were once the leading theory. These hypothetical particles interact through gravity and perhaps the weak nuclear force, but not electromagnetism, making them nearly impossible to detect. For years, massive underground detectors have waited silently for one of these particles to bump into an atom of xenon or argon. Decades have passed. Nothing. Other theories suggest axions, ultra-light, almost ghost-like particles that might swarm through space in vast numbers, forming a kind of quantum fog. Still others wonder if we're chasing phantoms because our understanding of gravity itself is flawed. Could it be that the laws of gravity change on large scales? The theory of modified Newtonian dynamics, or MOND, suggests just that. It's controversial, but the very fact that it's being considered tells you how strange and urgent this mystery really is. And here's where things get even more unsettling. What if dark matter isn't some distant exotic substance? What if it's all around us, passing through your body right now? Millions of particles every second, like phantoms drifting through the Earth without leaving a trace. Some estimates suggest that a dark matter particle travels through each human being once every few seconds. You don't feel it. You can't stop it. But it's there. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Tonight, we begin a journey not just through space, but through the mind, through everything we think we know about, the universe. Because if dark matter is real and all the evidence says it is, then the vast majority of the cosmos is made of something we don't understand at all. Is it hiding in plain sight? The year was 1933. In the cold silence of the Swiss Alps, a man named Fritz Zwicky was staring at the cosmos with a conviction few others shared. He was studying the Coma Cluster, a massive conglomeration of galaxies drifting hundreds of millions of light-years away. Using the Mount Wilson Observatory's powerful telescopes, Zwicky meticulously measured the velocities of these galaxies and compared them to the visible matter that should be holding the cluster together. What he found was nothing short of revolutionary, or to many at the time absurd. The galaxies were moving too fast, far too fast. Based on the mass visible in stars and gas, the Coma Cluster should have flown apart like a dandelion in the wind, but it held together tightly. The only explanation, Zwicky argued, was that there must be an enormous amount of unseen mass exerting gravitational force. He coined it dunkle Materie, dark matter. But in an era when even the concept of galaxies outside the Milky Way was still fresh in the public consciousness, Zwicky's claims sounded speculative, even outlandish. Many of his peers dismissed him as a maverick, a cranky visionary on the fringes of astrophysics. And yet, he was right. It would take over 40 years for the rest of the scientific community to catch up. In the early 1970s, Vera Rubin and her collaborator Kent Ford began observing the rotational speeds of stars in spiral galaxies. According to Newtonian physics, stars on the outer edges of a galaxy should orbit more slowly than those near the center, just like planets in our solar system. The farther they are from the central mass, the weaker the gravitational pull. But Rubin's data told a different story. The stars weren't slowing down at the edges. They were moving just as fast as those near the core. It was like watching a merry-go-round that defied the laws of physics. Rubin's work, conducted with quiet precision and unwavering confidence, confirmed what Zwicky had seen decades earlier. The visible matter wasn't enough. Something else was out there. Something invisible, massive, and everywhere. Her discovery shattered the cosmic mirror. Suddenly, the dark matter problem wasn't a quirky anomaly. It was a fundamental flaw in our understanding of the universe. From that moment forward, the quest to understand dark matter became one of the great pursuits of modern science. Physicists and astronomers began probing deeper, using ever more sophisticated tools to observe the universe in new ways. One such breakthrough came with the development of gravitational lensing, a phenomenon predicted by Einstein's general theory of relativity. When a massive object like a galaxy cluster lies between Earth and a more distant light source, its gravity bends the light, distorting the image and creating arcs, rings, or multiple reflections. These distortions allow scientists to see the gravity of the invisible. By analyzing the way light bends around massive objects, astronomers can map the distribution of dark matter, even if it emits no light of its own. One of the most compelling images of this kind comes from the Bullet Cluster, a collision of two galaxy clusters over 3 billion light-years away. In this cosmic train wreck, ordinary matter, like hot gas, slowed down during the impact, glowing brightly in X-rays. But the gravitational lensing showed the bulk of the mass had passed through unimpeded. Dark matter had not even flinched. It had moved on, unaffected by collision, radiation, or heat. Whatever dark matter is, it's not made of atoms. These visual confirmations sparked a frenzy of theoretical development. Particle physicists entered the arena, proposing candidates for what dark matter might be. The frontrunner for decades has been WIMPs, weakly interacting massive particles. According to the Standard Model extensions, WIMPs should have been created in huge numbers just after the Big Bang. They'd be electrically neutral, massive, and interact only via gravity and the weak nuclear force, perfect for dark matter, if only we could find them. This led to the rise of some of the most ambitious and imaginative experiments in modern science. Deep beneath the Gran Sasso mountain in Italy, inside a facility carved into the rock to shield it from cosmic rays, lies the xenon experiment. Picture it: a chamber filled with ultra-pure liquid xenon, so sensitive it can detect the smallest disturbances, perhaps even the nudge of a passing dark matter particle. Other experiments like LUX and LZ in the United States follow similar designs, all of them waiting, watching, hoping. Meanwhile, physicists turn to particle accelerators like the Large Hadron Collider at CERN, smashing protons together at near-light speeds in hopes of producing dark matter particles in the debris. But despite hints, suggestions and anomalies, the prize remains elusive. Decades of experiments, billions of dollars, and still no definitive detection. Yet rather than discouragement, this has only deepened the mystery and widened the search. In recent years, newer candidates have gained traction. Axions, lightweight, almost undetectable particles originally proposed to solve a completely different problem in quantum physics, have emerged as a possible explanation. There's even speculation that dark matter might be made of primordial. Black holes formed moments after the Big Bang, tiny ancient gravitational wells that could be drifting through space unnoticed. But here's the twist. The more we search, the more it seems dark matter is hiding in plain sight. It could be interwoven with gravity itself, or bound to particles we already know but interacting in ways we haven't imagined. Could it be tied to dark energy, the mysterious force causing the universe's expansion to accelerate? Are they two sides of the same invisible coin? The theories keep coming. So do the experiments. And the universe keeps pulling back the curtain, inch by inch. Now we'll explore the bold new frontiers where science meets speculation. What if dark matter isn't a new particle at all, but a misunderstood dimension of space, or even evidence of parallel realities? Could artificial intelligence and quantum computing finally crack the code? And if dark matter is right here with us, why can't we feel it? Imagine for a moment that the universe is not what it seems, that what we call reality is merely a shimmering surface, a visible ripple atop a much deeper hidden ocean. That ocean might be dark matter. As our instruments grow more precise and our theories more daring, a startling idea has emerged. Maybe we've been searching for dark matter in the wrong place, or in the wrong way. What if dark matter is not a thing to be discovered, but a feature of the universe itself? A twist in the cosmic architecture we've yet to comprehend. Let's start with something radical, something theoretical physicist Lisa Randall and her colleagues proposed. What if there is a hidden, dark sector? Just as the visible world is governed by particles and forces, protons, neutrons, electrons, photons, perhaps there exists a parallel realm of dark particles and dark forces. In this shadowy world, dark atoms might bind together, forming dark stars, dark planets, even dark life. It sounds like science fiction, but this idea is grounded in serious physics. These hypothetical particles would rarely, if ever, interact with ordinary matter, except through gravity. It's a bold thought, a ghost universe entwined with our own, invisible yet powerful, and then there's the possibility of extra dimensions. String theory, the wildly ambitious framework that seeks to unify all forces in nature, suggests that our universe may have more than the familiar 3 dimensions of space and 1 of time. Some theories propose as many as 10 or 11 dimensions. These extra dimensions might be compactified, curled up so tightly that we never notice them. But if gravity can seep into these hidden realms, then perhaps dark matter is not matter at all, but a gravitational echo from another dimension. What we interpret as an invisible mass holding galaxies together could be the residue of higher dimensional physics bleeding into our observable universe. Another theory takes this a step further. Some physicists speculate that dark matter could be evidence of brains, multidimensional membranes floating in a higher dimensional space. Our universe might be one such brain, and dark matter could be gravitational leakage from another, parallel brain just out of reach. In this scenario, dark matter is not within our universe but beside it. influencing it, like the faint tug of a nearby world. Now, take a breath. It's a lot to take in, right? And yet, this is exactly where the frontier of physics lives, at TRI. The blurry edge between what we know and what we suspect might be true. But let's bring it back to Earth, literally. Despite the cosmic scale of this mystery, dark matter may not be light years away. It could be right here, right now, flowing through your body, through the chair you're sitting on, through every atom on Earth. According to astrophysical models, our planet is drifting through a galactic halo of dark matter. Every second, trillions of dark matter particles might be passing through us, and yet we feel nothing. That's what makes the search so maddening. It's like trying to catch the wind with bare hands. Still, scientists press on. At the cutting edge of this quest are novel experiments that combine cutting-edge technology with imaginative design. Take quantum sensors, for instance. Devices so sensitive they can detect the tiniest shifts in space-time. Researchers hope these sensors might be able to pick up the influence of passing dark matter particles, especially if they subtly affect the quantum behavior of atoms. The emerging field of quantum metrology could offer the breakthrough we've been waiting for. Meanwhile, artificial intelligence is transforming the way we process data. Telescopes like the Vera C. Rubin Observatory are collecting petabytes of information, more data in a week than humanity gathered in centuries. AI algorithms sift through this ocean of numbers, looking for patterns, anomalies, subtle distortions in gravitational lensing, or even unexplained fluctuations in galaxy movement. One day, buried in that data, AI might stumble upon the fingerprint of dark matter. Even more provocative are experiments involving ultra-cold atoms, clouds of atoms, chilled to nearly absolute zero and suspended in magnetic traps. At these temperatures, matter behaves like a wave rather than a particle. If dark matter interacts with ordinary matter even slightly, it might leave behind a detectable ripple, a whisper in the chill of absolute silence. And then, there are the mysteries we didn't even know we had. In 2022, astronomers discovered a galaxy called DF2, an ultra-diffuse galaxy that seems to contain no dark matter at all. This was shocking. If dark matter is essential to galaxy formation, how could a galaxy form without it? Some thought it might be a fluke, but then came DF4, another galaxy with seemingly no dark matter. Are these just statistical outliers? Or cracks in the theory? Could it be that dark matter isn't as uniform as we thought? Or are we looking at something else entirely? Others look to the small, antimatter experiments, high-energy gamma-ray observations, even cosmic ray collisions. Some physicists suggest dark matter might occasionally annihilate with itself, creating detectable bursts of energy. The Fermi Gamma-ray Space Telescope has recorded mysterious emissions from the center of our galaxy. Some suggest they could be signals of dark matter particles colliding. Others argue it's just pulsars. The jury is still out. As we push further, the question becomes more than just scientific. It becomes existential. What does it mean to live in a universe where the majority of its content is invisible, unknowable, and untouchable? How do we redefine our understanding of reality when the most dominant substance in the cosmos is hidden from every sense we possess? If dark matter is not a new particle or force, but something stranger, are we ready to face what that means? Close your eyes for a moment and picture the universe, the swirling galaxies, the dance of planets around distant suns, the majesty of nebulae stretching across light years. Now, strip all that away. The stars, the gas, the dust, gone. What's left? Not emptiness, but something more mysterious. A cosmic scaffolding, an invisible architecture holding it all together. This is dark matter. But what if it's more than just a cosmic glue? What if it's not a missing piece of the puzzle, but a clue to an entirely different puzzle altogether? As we reach the edge of scientific understanding, we also arrive at the doorstep of something deeply philosophical, perhaps even spiritual. Because to truly confront dark matter is to confront the limits of human perception. We have built our worldview on what we can see, touch, measure. And yet, the universe whispers a different truth, that most of reality, over 80% of all matter, is hidden in plain sight. Some physicists now suggest that dark matter might not be matter in the conventional sense at all. What if it's a new property of space-time, a curvature, a pressure, or a field woven into the very fabric of the cosmos? The idea sounds radical until you realize it echoes something Einstein once considered, that gravity itself might emerge from deeper laws of thermodynamics and information theory. In that light, dark matter could be the universe's version of static, an echo of deeper hidden laws we haven't discovered yet. Even more provocatively, a growing number of scientists are exploring modified gravity theories. One such proposal is MOND, modified Newtonian dynamics, which suggests that gravity behaves differently on cosmic scales than we once believed. Instead of unseen matter holding galaxies together, maybe gravity itself gets stronger at low accelerations. It's a controversial idea, but some galactic observations align better with MOND than with traditional dark matter models. Could it be that we don't need new particles, just a new understanding of force itself? Still others suggest something even more mind-bending, that dark matter might be linked to consciousness. Yes, you heard that right. This fringe idea posits that dark matter could be connected to the structure of information in the universe, something beyond particles and waves. Could the strange elusiveness of dark matter stem from its entanglement with how consciousness observes reality? We know from quantum mechanics that the observer affects the observed. Could dark matter exist in a state that eludes detection because it resides outside our conventional modes of observation? Of course, this veers deep into speculative territory, but that's where all revolutions begin. Let's not forget, at the dawn of the 20th century, people believed the universe was static and the Milky Way was the entire cosmos. Then came Einstein, then Hubble, then quantum mechanics. Each step shattered our assumptions and redefined what was possible. Dark matter may be the next revolution, or the bridge to something even greater. Some futurists argue that cracking the dark matter mystery could become the gateway to advanced technologies we've only dreamed of, propulsion systems based on gravitational control, dark energy manipulation, maybe even access to dimensions beyond our own. If dark matter holds secrets about the structure of the universe itself, then understanding it might unlock tools as powerful as the discovery of electricity or nuclear energy. Others wonder, what if we're not the only ones trying to understand it? Think of it this way. If intelligent alien civilizations exist, and statistically it's hard to argue otherwise, then they too must have encountered this enigma. Could dark matter be the shared mystery that links us all across time and space? A kind of cosmic Rosetta Stone, waiting for those advanced enough to decipher it? And if dark matter is a doorway, who or what is on the other side? This is where science blends with wonder, and curiosity meets the infinite. Because maybe, just maybe, dark matter isn't hiding. Maybe it's inviting, waiting for us to evolve our senses, our instruments, our understanding, so we can finally see the full tapestry of the universe, and not just the glowing threads. So now the question isn't just, what is dark matter? The real question is, are we ready to see what lies beyond? Because the search isn't over. In fact, it may have only just begun. If this journey through the shadows of the universe sparked your imagination, share this video with someone who dares to ask questions. Hit the like button if you believe that curiosity is our greatest tool, and leave a comment below. What do you think dark matter really is? A particle, a force, a key to another universe? We want to hear your theories. After all, the universe is full of mysteries, and the next great discovery, it might just start with you.